All right, welcome to Solving by Graphing Part 2. And I've already put an example here. Y equals 2x squared plus 4x minus 3. And then a linear equation, y equals 2x minus 1. And we're going to try to solve this. So the real work is graphing both of these equations. So I'm going to start with the first one here. And in order to best graph this, I'm going to grab some decent points. First thing I need to do is figure out the vertex. So I'm going to do a little rearranging here. I am going to take that 2 and factor it out. So factor it out of the x squared and out of the 4x. I'm going to leave a little space, and then I got minus 3. So there's my first step. Now I'm going to take half of 2, which is 1, squared is 1. That will complete the square. Now I just put in a 2, so I better take a 2 out to compensate. So here's my factored form. It's going to have 2 out in front, and then we're going to have x plus 1 all squared. And then these two numbers together make minus 5. So a little quick rearrangement, and now I can see where the vertex is. So I go, okay, yep. That vertex is at negative 1, because that'll turn this to 0, minus 5. Okay, so I got my vertex. Maybe some real quick, easy points. The y-intercept would be, of course, when x is 0. And I'm just going to go over here to the original general form, 0, 0, negative 3. Okay, so, and maybe it'd be pretty good to get those x-intercepts. Where are they going to be? Well, all I know is that they're going to be the points that have a 0 for the y. So I'm going to have to do a little bit of solving here. So we're going to put in a 0 for the y, and then leaves us with 2 times x plus 1 all squared minus 5. So bring that 5 over and also divide by 2. That'll get rid of the 2 that's in front. And lastly, I'm going to square root both sides. Okay, so this will be plus or minus. And that's going to get rid of the squaring over here. So I'm going to have plus or minus the square root of 5 halves. And that's going to equal x plus 1. Now I'm going to save myself a little trouble and just bring that 1 to this side. So these are my x-intercepts. I just got to work them out. Now I went ahead and did that on the calculator. And if I went negative 1 plus the square root of 5 halves, I got 0.58, or maybe I just even round it to 0.6. And if I went negative 1 minus the square root of 5 halves, I got negative 2.6. Okay? Now that's everything I need to make a pretty good graph. Okay, now what about if I was graphing this line? Well, let me just point out a few important things. That would be the slope. And over here, this negative 1 is the y-intercept. Okay, so those are all the important ingredients. I would plot this point first. So I would plot the point 0, negative 1. And then I would build a slope of 2, which I would think of as 2 over 1. So it means up 2 over 1, up 2 over 1. Okay? Now all this stuff is taking up all kinds of space. So I'm just going to delete it. So hopefully you got it all in front of you. Clear this away, and then I'm hoping that if I hit paste here, my grid shows up, which it just did. So I'm very happy about that. So I'm going to start maybe with the line. That one's freshest in my mind. My y-intercept is down here at negative 1. And then I want to build up 2 and over 1. Okay, up 2 and over 1. And that's probably good enough. I'll see if I can use this line draw feature and draw in a pretty good line here. So let's see if that actually works well. Not too bad. Okay, there's my line. Okay. Now I'm going to plot all the important points for my parabola. I've got my vertex at negative 1, negative 5. So 1, 2, 3, 4, 5. It's down there. And then I've got my y-intercept at 0, -3, which of course, due to the symmetry of a parabola, I can just reflect it over to this side as well. Then I got my x-intercepts at 0.6, so right about here actually, and -2.6, so something like that. Okay, so I got all my important points. Now I can see what's going to happen. I got a parabola down this side here, and of course the tricky part for me on this little tablet is to draw it half decently. Alright, so not the greatest drawing, but you know what? Because I'm working on a grid, I think I got some reasonable answers. Here's what I got. There's one of my solutions right here. And this would be maybe, it looks like when x is what? Maybe -1.6, maybe -1.6. And then the y value is -1, 2, 3, 4. Pretty close to -4. Okay, so I'm going to say that's pretty much my solution there on the left side by graphing. And then I got an intersection point right around here. This is pretty close. It looks like 0.9 or even 1. And then it looks like maybe 0.8. Okay, so these would be my two solutions. And yeah, good enough for this first example. So I'm going to clear the screen, and I'm going to do one more example that's a little bit different from this. This one was, you've got the quadratic equation which graphs as a parabola, and then the linear equation which graphs as a line. But what if you got something quite different, maybe something like this, that's quadratic. So -2x² plus 2x plus 4. Okay, so that's quadratic. That's going to be a parabola. What if we have another parabola? Okay, well, it's really no big deal. The work is really just finding all the necessary ingredients for an accurate graph. So what I'm going to do is, with this top one, we might as well start by factoring out -2. I mean, you kind of need to know where that vertex is. So you just kind of hope you don't run into too many ones with fractions. So let's see here. We've already factored out -2, so I just need to have -x here. Then we'll leave a little space, so we got plus 4. So I need half of 1, which is 1/2. Squared is 1/4. Now what we actually put in here was -2 times 1/4, which is -1/2. So I'm going to have to add 1/2 to that. Okay, now let's write it in its factored version. And we might even go to decimals on this just because we are trying to produce an actual graph. So this would be -1/2, which I'm going to write as 0.5. And over here, I'm just going to call this 4.5. Okay, so decimals are just fine when it comes to producing the graph. So here's where the vertex is for this graph. We've got positive 0.5 and positive 4.5. Okay, so there's our vertex. Maybe we'll do the y-intercept next. Let's put in 0, and we go here 0, 0, 4. Okay. Now I'm thinking here, let's see, we probably should throw in those x-intercepts as much as I don't want to, but this point here is kind of bunched close to that one, and that usually doesn't make for a very accurate graph. So I'm going to have to go and figure these out. But it's not that much work. We'll put in a 0 for the y, and then we got the rest of this stuff, right? So I think we can zip through it pretty fast. Okay, we're going to subtract the 4.5 over to the left side. And at the same time, I'm also going to have to divide by -2. So I might as well do that in one step. And that leaves me with x minus 0.5 squared. And you know what? I'm going to have to square root all this stuff, right? So I might as well do that at the same time. You can see it starts to get pretty repetitive. And that's the way I get rid of this squaring. And then I'm going to take this mess here, and I'm essentially going to add 0.5 to it. So here's what my x-intercept is going to look like. I'm going to have a positive 0.5 plus or minus the square root of whatever this mess is. At least I know it goes positive. And if I divide the 4.5 by 2, I get 2 1/4. So there's my decimal version. That's the easiest way to do it. So what are these guys going to look like? Well, I worked them out ahead of time. And these actually work out quite well, believe it or not. You get 2 and you get -1. Okay, so that's pretty good for the top equation. Now I'm going to work on this bottom equation, and luckily I chose one that wasn't going to be too much work. The vertex would be at 0, -5. Okay, the y-intercept is the same as the vertex, so it's really no help. And the x-intercepts, well, if we just go ahead and solve this equation, pretty quick to solve. Just going to add the 5 over, okay, and then I'm going to square root it, right, just to get rid of the squaring, and that'll be plus or minus. So I'm going to work out the decimals on that one, and I got plus or minus 2.24 for x. So those are my x-intercepts. That's everything I need. Now, unfortunately, I also need room. So I'm going to hit delete, and I'm going to paste in a grid and try and do a decent job of creating these graphs. So I take the first one. You'll recall we had the vertex at 0.5 and up to 4.5, so right about here. And then we had the y-intercept was at 0, 4. Okay, and that'll be symmetrical, so it'll be there. And you can see why I needed those x-intercepts. It's just so bunched up here. It's the only accurate way to get my graph. So I got -1 and +2. Now, let's see if I can draw this thing. Okay. All right. Whoopsie. Slipped on that one. Okay, so, whoops. It's a little wavy here, but you get the idea. And same thing over here. All right, so there's my first parabola. Now I'm going to draw my second one. And so I had a vertex at 0, -5. 1, 2, 3, 4, 5 down here. And then I had x-intercepts at 2 and a little bit. So right, -2 and a little bit, +2 and a little bit. Okay. So let's see if we can get this guy half decently drawn. Okay, again the waviness, but that's okay. Whoops. All right, and I really don't need to extend this much further. Good enough. Now, all I'm looking for is these points of intersection. There's one, and there's one. And if I make them nice and big, then I'm more accurate. Well, actually not. Okay, so where is this guy? Negative 1.5, and it looks like it's down to 1, 2, 3, so -3. Okay, that's not too bad. And the other one over here looks like it is at 2 and a bit, maybe 2.2, and it looks like we're down at maybe -0.8. All right, so there are my two solutions done by the method of graphing. And that's where I'm going to stop with graphing.